Alright, let's do this. Alright, so this is the game that I made in Scratch, the MIT game building thing. It was inspired by a game called crazygame.exe, where you were a spaceship and you just had to move around and avoid these random projectiles going all over the screen. So that's kind of what I reproduced here. Now, one change that I made, though, is that an improvement I made over crazygame.exe is that if the arrow... Oh, God, that was close. So if the arrow touches your sprite, you don't actually lose right away. The arrow... Oh, no. That was close. If you know games like Toho, where the entire sprite is, oh god, not hittable, only a small square in the middle can actually get hit. So that's what I've done here. You can only get hit if the center of your pufferfish gets hit, you lose. Oh my gosh, and also it gets faster. Oh god. Yeah. That's what happens when you lose. So there's a timer up at the top here that tells you how far you've gotten. I got about 32 seconds by Scratch time anyway, but not real seconds. Yeah, and the ticking, by the way, every time that tick happens, the game gets a little bit more difficult. So you'll know if you've reached like maximum difficulty when the ticking stops, because then it's like, okay, we're done making this game harder. Yeah. I'm gonna try and put this somewhere, and then if you want, you can try it yourself, or you can like modify it and just experiment. Because I mean, this is now like the start of a shoot 'em up game, basically, right? You just have to change where the arrows are coming from, maybe give the player an attack as well, and yeah, it's the start of a shoot 'em up game. All right, I'm gonna give this one more go. I mean, or am I? But it won't fit the glitch clip. I guess I can highlight it. All right, we gotta break that. I want to get at least 400. Okay, focus, cuckoo. I see everything. Oh god, I see everything, and I don't like what I see. Oh god. Focus. I hear someone upstairs. I hope I'm not being too loud. No, we have to focus on the game. Don't focus on what. No, I'm dead. Oh, there you go. If you play the game, I hope you have fun. Okay, I guess you know what? Let's quickly go over what this game looks like too, actually. So, because I don't want anyone to have to watch the entire stream to find out what the heck my game is doing. So if you just came for the clips to watch me play and get blown up, that part is over. Now I'm just going to explain how the game works. Okay, so this is your player, right? Let me just make sure nobody told me to STFU. Okay, good. I'm talking pretty softly. Please give me a nice song for this. Thank you. Okay, so what we've got here, this is what the player does. When the game starts, player starts in the middle, like that. They always point direction 90. The reason I had to do that is because later on, like if you bounce the edge, right? If I run to the edge, I can't go beyond the edge. It's kind of like bounce off of it. But I found out that when you do this, you say if on edge bounce, it actually changes your direction. So I had to, that's why like here, whenever you bounce, it sets the direction back to 90. Yeah, so I guess I don't really need this one here, but anyway. So here we have a variable player hit. This is what we call a flag. If it ever gets set to 1, the player got hit. And then if that ever happens, like if the player gets hit, we're going to play that sound effect, and then we're going to hide the player. So let's see, we set our speed to 5. We can change our speed here. Pretty easy to change the speed. That's one of the uses of variables when you're programming and stuff, is that like, let's say I wanted to change my speed to 6. If I didn't have a variable here, I'd have to change the speed in all 4 of these places, and that's pretty annoying, right? Like, what if I want to try like 10 different speeds, if I want to experiment? Really easy to do if I just have to change the speed in one place. So that's what that's there for. In the business, we call that a constant. And then we have our score. And the score obviously just counts up. In fact, that's what's down here. So until you get hit, every 0.1 seconds, roughly, we're going to increase the score by 1. That's why it counts up. Yeah, and of course, once you get hit, we play the sound and hide you. Oh yeah, and at the start, we have to show the sprite. That's pretty important. This thing here, forever, this just stops you from going beyond the edges of the screen. If you're touching the edge, bounce. And lastly, oops, see, this over here is our movement script. Just we're in a loop, and whenever you're pressing a key, like if you're pressing right arrow, increase X, pressing left arrow, decrease X by speed, and so on and so forth. So let's look at the hitbox now. The hitbox is actually like right, you can't, it's right there in the middle. You can't really see it. That's because right at the start of the game, we're gonna show the hitbox because technically you can't see the hitbox, but if we don't show it, then Scratch will not check for collisions with the hitbox. So we need to show it, but then we hide it behind the pufferfish by sending the hitbox to the back layer. And then forever, we're just going to constantly go to wherever the pufferfish is. That's why our hitbox is always in the middle of the pufferfish. If I change this to front and play the game, you can see that the hitbox is always going to be in my middle, even if we bump into the top. Like that. And you'll see that once the hitbox actually gets hit by an arrow. Oh, that was close. There it is. Yeah. And that's what, well, the collision is actually done in the arrow, but you'll see why in a sec. So, oops. So yeah, let's change this back. So that's our hitbox. Oh yeah, and of course, once the player's hit, we also hide our hitbox. All right, now let's finally look at the arrows. Both of the arrows do the same thing. Arrow 2 is just a duplicate because I want arrows to spawn in 2 at a time. But otherwise, they're exactly the same. So our arrow, here's our arrow's constants / variables. We have a max X and max Y. That determines where it spawns around the edges of the playing field. I'll get to that. This big thing here. I'll explain that last. Our speed is, of course, the arrow speed. Max size is how big the arrows are. And you know what? Maybe I can make this smaller to make it more of like a Toho game. Well, anyway, that's an improvement I guess you can make. And lastly, we have the new arrow interval. So every 0.5 seconds, we make a new arrow. And then the reason we hide this is because there's like, so somewhere around here, over here, there's an arrow, but it's not it's like the base arrow, I guess. It's like the prototype arrow. We're gonna hide that arrow, but we're gonna keep cloning it, and the clones are what are gonna attack the player, not the original arrow. The original arrow just chills over there and doesn't do anything. So it's hidden. Yeah, oh, also the original arrow will clone itself every interval, new arrow interval. So every 0.5 seconds. Create a clone of myself. Wait, what else can go here? Oh, that's cool. Okay. And then another thing we do is, oh, this is the difficulty increase. In fact, I'm going to comment that right here. Let's see. Increase difficulty. Because it's not obvious what's going on here. This is increasing difficulty. Let me maneuver things over here so you can see what's going on. Okay. There we go. What's down here? Is this also... Oh, this also increases difficulty here. Increase difficulty. Yeah, so there's 2 different things that increase difficulty. The first one, okay, so every interval. Well, actually, the reason there's a repeat until loop here is that basically we're going to increase the difficulty until new arrow interval falls below some number. We're going to call that the minimum arrow interval. So once we're below 0.01 seconds, we're going to stop looping and we're just going to set the arrow interval to 0.01 seconds, and that's it. That is the most difficult, fastest arrow interval. But until then, every 2 seconds, we're going to decrease the arrow interval so that they come faster and faster. And that's also when we play the clock sound. The reason why the clock sound is in this loop is because this loop will actually loop more times than down here. This is the speed loop. And again, we're going to keep looping until our speed exceeds 5, because that's our maximum. Once our speed exceeds 5, we come down here, set our speed to 5, And that's it. That's like as fast as they go. And every second, our speed's going to increase by 0.1. So the speed will slowly go up to 5. And because of the initial values these start at, speed starts at 2, and our interval starts at 0.5. If you do the math, the speed is going to reach 5 before the arrow interval reaches its minimum value, 0.01. That's also why the clock ticking is in here, because this is going to run longer. The speed will hit its max a lot sooner than that. So yeah, so this is what increases our difficulty. This thing makes copies of the arrow. This thing is just setting variables and constants. Okay. Oh shoot, what did I do? Is that in here? Yeah, okay. So what's down here is, let's see. Oh, you know what? We're gonna add a comment here. We're gonna say appear. Arrow appears. Yep, so this is where the arrow appears. So we start at a size of 5%, and then until our size goes above max size. So remember, our max size we set to 50 or 50%. So until we reach 50%, we're just gonna increase our size. Change size by, oh yeah. So our size starts at 5%, right? And until size goes above 50%, we're just gonna increase our size by 2.5%. And eventually our size will reach 50% and exceed it. At that point, we break out of this loop. We set our size to exactly the max size, 50%. And then over here we have collision detection. This one we're going to say make arrow appear. Make arrow appear. There we go, make arrow appear. Okay. So, oh wait. Actually, the collision detection, oops, hang on. This is actually collision detection here. This is I mean, I guess that's self-explanatory. Until the arrow hits the edge of the playing field, the arrow's going to move, and if the arrow ever touches the hitbox, not the player, but the hitbox, then we set player hit to 1, which is basically saying the player got hit. And if you remember in the player events, when player hit is equal to 1, that's when we stop this loop and we hide our player and we play the sound effect. So player hit equals 1 means, well, you got hit. That also stops giving you score too. Okay, so there's our collision detection. And of course, once you do touch the edge of the screen, we stop this loop and we just delete the clone. So it goes poof. Yeah, this is so whenever the clone appears, we show it, goes to the front layer so that the clone appears on top of the player. This is what makes the arrow appear. Then it reaches its max size, and then we wait until it touches the edge, we move it, and do collision detection with the player's hitbox. And now, finally, we move on to maybe the most complicated piece of code. It's up here. Okay, let's move over here. This is going to be move arrow to random location. There we go. Okay, so we have a variable here called starting edge. We're going to set that to a random thing between 1 and 4. That's which edge we're going to start along. If starting edge is equal to 1, it's on the top. If it's equal to 2, it's on the bottom. If starting edge is 3, it's on the right, and 4 is on the left. So let's see what happens here. If our starting edge is less than 3, that means it's top or bottom, 1 or 2. So for both cases, if you start at the top or the bottom, we're going to take our x coordinate and set it to somewhere between negative max x and positive max x. And max x we set to 220. That means our x coordinate is going to set somewhere between negative 220 and positive 220. Then we need to pick whether we're on the top or the bottom. So if starting edge is 1, the top, I'm going to put these here. So if starting edge is equal to top, then y coordinate is set to maximum y, that's up here. Specifically, that's to 160. So y is set to 160, and otherwise, starting edge is equal to 2, our y is set to negative 160, and that's down here. And then it's the same situation when you start on the right or the left, 3 or 4. We pick a random y coordinate between up here and down here, and then we decide, well, if we're on 3, we start at max x, which is over here, and if it's equal to 4, we start on the left edge, negative max x. So yeah, that's how we move the arrow to a random location. Let's say move the arrow to a random location around the edge. Here, edge. There we go. Move arrow to random location near random edge. Okay, and lastly, once we've picked our random location for our arrow, we're gonna see here. We're gonna point the arrow in a random direction that's vaguely in the player's direction. So let's add a comment here. Random direction, or it's a point towards a random direction that is vaguely in the player's direction. There we go. And point towards a random direction that's vaguely in the player's direction. Okay. So yeah, that's all the code that I wrote. That's it. It's just these this and this. All right. Well, that's the crazy game code. I guess I'll probably highlight this on Twitch and upload it to YouTube. The explanation of my little game. I'll put this somewhere. I guess check the video description on YouTube to find out where Cuckoo actually put this game. And yeah, I hope you've enjoyed. I hope you'll download this, I guess, and try it out. Play the game, have some fun, and maybe edit some things too, you know? Go do it, do whatever you want. Have some fun. All right, I better stop now. So I hope everybody have yourself a good day whenever you're watching this. And I'm going to have myself a good night. See ya.